Hello everyone, myself Purva Joshi. Today we are going to study few more topics of complex number. So let's start with the first topic, that is circular function. Now from Euler's formula, e raised to I theta is cos theta plus I sin theta, and e raised to minus I theta is cos theta minus I sin theta. Okay, so from this, if you add this two term, okay, so I sin theta will get cancelled, okay, and you will get the answer of cos theta as 1 upon 2 e raised to I theta plus e raised to minus I theta. Okay, and if you subtract this two, okay, you will get the answer of sin theta as 1 upon 2i e raised to I theta minus e raised to minus I theta. Okay, now if z is x plus iy, which is a complex number, okay, then cos z will be e raised to iz plus e raised to minus iz upon 2, and sin z is equal to e raised to iz minus e raised to minus iz upon 2i. Okay, and these are called circular functions of complex number. Now let us prove some result. First is sine inverse z is equal to minus I ln iz plus under root 1 minus z square. Okay, and then we have to find sine inverse minus I. Okay, so let's start with the proof. So firstly, let sine inverse z is equal to y. Okay, so z is equal to what? Sine y, right? Now we know the formula for sine y, that is e raised to iy minus e raised to minus iy, okay, upon 2i. Now take this 2i over here, so this is 2iz is equal to e raised to iy minus e raised to minus iy. Okay, now we will take out e raised to minus iy. Okay, so what you will get over here, e raised to 2iy minus 1, right? Now this e raised to minus iy we will bring over here. Okay, so you will get 2iz e raised to iy is equal to e raised to 2iy minus 1. Now from this, take this 2iz e raised to iy to this side, so we will get e raised to 2iy minus 2iz e raised to iy minus 1 is equal to 0. Okay, now we have this quadratic equation and we will find the roots. Okay, so we'll find the roots of e raised to iy using the formula minus b plus or minus under root b square minus 4ac upon 2a. Now here a is 1, okay, b is minus 2iz and c is minus 1. Substitute everything over here, so you will get 2iz plus or minus under root b square, so you will get 4i square z square, okay, and minus 4 into 1 into minus 1, so here we have plus 4, okay, and upon 2. Now this is 2iz is plus or minus. Now we can take out 4, okay, common, so here we have 2, and I square is minus 1, right? So this is 1 minus z square upon 2. We can take out this 2 common and this 2 will get cancelled. Therefore e raised to iy is what? Iz plus or minus under root 1 minus z square, right? Therefore iy is what? Ln iz plus or minus under root 1 minus z square. Okay, so from this y is equal to what? Sine inverse z. Now bring this I in the denominator, so we have 1 upon I ln iz plus or minus under root 1 minus z square. Now multiply and divide by I over here. Okay, so this is I square, that is minus 1. So finally the answer of sine inverse z is what? Minus I ln iz plus or minus under root 1 minus z square. Okay, this is the result we want to prove. Now we have to find sine inverse of minus I, right? Therefore in place of z will substitute minus I. Okay, in place of z substitute minus I. So this is minus I ln, now here I into minus I, okay, plus or minus under root 1 minus minus I square. So simplify this, right? So minus I ln. Now this is I square, okay, and minus or minus minus will become plus. So this is 1 plus or minus again. This is I square, that is minus 1. So it will become plus 1. So here we have under root 2, right? So this is the answer. Now let's move to the next result. So we have to prove that tan inverse z is equal to I by 2 log I plus z upon I minus z. So again, suppose tan inverse z is equal to y. Okay, so from this z is equal to what? Tan y. Now tan y is what? Sin y upon cos y. Now we will use the formula of sin y upon cos y. So this is 1 upon 2i e raised to iy minus e raised to minus iy. Okay, and here we have 1 upon 2 e raised to iy plus e raised to minus iy. Okay, now this 2 will get cancelled. Okay, so what you will get, z is equal to e raised to iy minus e raised to minus iy upon I into e raised to iy plus e raised to minus iy. Okay, bring this I over here. Okay, so this is iz is equal to e raised to iy minus e raised to minus iy upon e raised to iy plus e raised to minus iy. Now we'll multiply and divide it by I over here. Okay, so what you will get here, I square. Okay, that is minus. Okay, so here we have minus z upon I is equal to e raised to iy minus e raised to minus iy upon e raised to iy plus e raised to minus iy. Now we will bring negative sign over here. Okay, so we will get z upon I as minus e raised to iy plus e raised to minus iy upon e raised to iy plus e raised to minus iy. Now we will use the componendo and dividendo rule. Okay, but here what we will do, will proceed like this, that is I plus z upon I minus z, that is denominator plus numerator upon denominator minus numerator. Okay, same process will apply over here. Okay, so this is e raised to iy plus e raised to minus iy. Okay, now add. So this is minus e raised to iy plus e raised to minus iy. Now again denominator minus numerator. So this is e raised to iy plus e raised to minus iy. Okay, now we have to subtract. So this will become plus e raised to iy and here minus e raised to minus iy. Now over here this e raised to iy will get cancelled and here e raised to minus iy will get cancelled. So what you will get, I plus z upon I minus z is equal to 2 times e raised to minus iy upon 2 times e raised to iy. This 2 will get cancelled. Okay, therefore I plus z upon I minus z is equal to e raised to minus 2 iy. Okay, so from this what you will get, minus 2 iy is equal to what, ln I plus z upon I minus z. Make y as a subject. Okay, so from this you will get y is equal to, y is what, tan inverse z. Okay, so y is equal to tan inverse z. Bring this minus 1 upon 2i in the denominator, so minus 1 upon 2i. Okay, and this is ln I plus z upon I minus z. Now we will multiply and divide by I. Okay, so here multiply divide by I. So this is in denominator we have I square. It is minus 1, so this minus will get cancelled. So finally answer of tan inverse z is what, I by 2 ln I plus z upon I minus z, which is the required result. Okay, now let's move to the next topic, that is hyperbolic function. Now if z is a complex number, then cos hz is equal to e raised to z plus e raised to minus z upon 2 and sin hz is equal to 1 upon 2 e raised to z minus e raised to minus z. Okay, now from this expression other hyperbolic functions can also be obtained using the formula tan hz is equal to sin hz upon cos hz, cosec hz is equal to 1 upon sin hz, Sec hz is 1 upon cos hz and cot hz is 1 upon tan hz. Okay, so we will use the formula of cos hz and sin hz to derive the formula of all these hyperbolic functions. Now, sin h of minus z is what? Minus sin hz, because sin is an odd function, and cos h of minus z will give you cos hz because cos is an even function. Okay, now let's prove some relation between circular and hyperbolic function. So first is sin iz is equal to I sin hz. Okay, so we'll use the formula of sin z, that is e raised to iz minus e raised to minus iz upon 2I. Okay, now we will replace this z by iz because we want the result of sin iz, right? Therefore, sin iz is what? E raised to I into iz minus e raised to minus iz upon 2I. Okay, now this is e raised to I square z minus e raised to minus I square z, okay, upon 2I. Now we know the answer of I square is minus 1. Okay, so this is e raised to minus z minus e raised to, it will become plus. Okay, so e raised to z upon 2I. Now, firstly we'll take out minus common, right? So sin iz is what? Minus e raised to z minus e raised to minus z upon 2I. Now we'll multiply and divide it by I. Okay, so this is I square. Okay, and I square is minus 1. This minus will get cancelled. So finally what we have? I times e raised to z minus e raised to minus z upon 2. Now we know that this formula is what? Sine hyperbolic z. Okay, hence we have proved the result that sine iz is equal to I sine z. Now the next is cos iz is equal to cos hz. So we'll use the formula of cos z, that is e raised to iz plus e raised to minus iz upon 2. Okay, now we'll replace this z by iz. Okay, so you will get cos iz as e raised to, now I into iz. Okay, so this is I square z plus e raised to minus I square z upon 2. Again use the formula of I square, that is minus 1, so you will get e raised to minus z plus e raised to z upon 2. Now we know that this is the formula of cos hz, hence we have proved the result that cos iz is equal to what? Cos hz. Okay, now the next result is tan iz is equal to I tan hz. Okay, and from this we will prove that tan hz is equal to minus I tan hz. So firstly tan iz, okay, this we can write as sin iz upon cos iz. Okay, now we know the result that sin iz is I sin hz, okay, and cos iz is cos hz. Okay, so this is I tan hz. Okay, so the first result, that is tan iz is equal to I tan hz, is proved. Okay, now from this bring this I over here. Okay, so you will get 1 upon I tan iz is equal to tan hz. Okay, therefore tan hz is what? Multiply and divide it by I. Okay, so in denominator we have I square, that is minus 1, so we have minus I tan iz. Okay, so this is the second result which we have to prove. Now the next topic is separation into real and imaginary parts. Okay, so to separate real and imaginary part of the complex number, we will use the following result. So the first one is sin x plus or minus iy. Okay, so we'll apply the formula of sin alpha plus or minus beta. Okay, that is sin alpha cos beta plus or minus cos alpha sin beta. Now we will use this result, that is sin iz is equal to I sin hz and cos iz is equal to cos hz. Okay, we will use this two result. So in place of here cos iy, we will write cos hy, and in place of sin iy, we will write I sin hy. So here this is the real part and this is the imaginary part we have separated using this result. Similarly, here we will apply cos alpha plus or minus beta formula. Okay, and again in place of cos iy we will write cos hy. In place of sin iy we will write I sin hy, and we can separate the real and imaginary part. Okay, again using this two result we can derive this following result. All right, now there are few formulas on the hyperbolic functions. Okay, this is the formula of sine 2 theta cos 2 theta. Okay, just in the hyperbolic form. Also we have this formula which we have to remember. Okay, now let's move to the next topic, that is inverse hyperbolic function. So if x is equal to sine hu, then u is equal to sine h inverse x. Okay, and this is called a sine hyperbolic inverse of x, where x is a real. Okay, similarly we can find cos h inverse x, tan h inverse x, cot h inverse x, sec h inverse x, and cosec h inverse x. Okay, now let's prove some result. So first one is sine h inverse x is equal to log x plus under root x square plus 1. So again, we'll suppose this sine h inverse x as y. Okay, so from this you will get x as what? Sine hy. Now we will use the formula of sine hy, that is e raised to y minus e raised to minus y upon 2. Okay, bring this 2 over here. So you will get 2x is equal to e raised to y minus e raised to minus y. Take out e raised to minus y common. So here we have e raised to 2y minus 1. Bring this e raised to minus y over here. So you will get 2x e raised to y is equal to e raised to 2y minus 1. Okay, from therefore e raised to 2y minus 2x e raised to y minus 1 is equal to 0. So this is a quadratic equation. Okay, and we have to find the roots of e raised to y. So using the formula minus b plus or minus under root b square minus 4ac upon 2a. Okay, now here a is 1, b is minus 2x, and c is minus 1. Substitute the value. Okay, so this is 2x plus or minus under root here 4x square, 4 into 1 into minus 1, so this is plus 4 upon 2. We can take out this 4 common, so 2 will be outside. We'll take out that 2 also. Okay, and it will get cancelled with this denominator. So finally we have x plus or minus under root x square plus 1. Okay, so from this y, okay, so y is what? Sine h inverse x. Okay, so this is equal to what? Ln x plus or minus under root x square plus 1, right? So this is the desired result. Now let's prove this result. Okay, now we again we have to follow the same procedure, that is cos h inverse x is equal to y. So x will be cos hy. Apply the formula of cos hy. Okay, and simplify. Okay, so you will get this result, right? This you can do it by yourself. Now the next result is tan h inverse x is equal to 1 by 2 log 1 plus x upon 1 minus x. Again the method is same. Okay, we have to suppose this tan h inverse x is equal to y, therefore x will be tan hy, right? And we'll use the formula, that is the sin hy upon cos hy, right? So this is e raised to y minus e raised to minus y upon 2. Here e raised to y plus e raised to minus y upon 2. This 2 will get cancelled, right? Therefore x is what? E raised to y minus e raised to minus y upon e raised to y plus e raised to minus y. Now in the denominator we can write it like this. Okay, now we will use the componenter dividend rule, but again denominator plus numerator upon denominator minus numerator. Okay, so this is e raised to y plus e raised to minus y, add them, so plus e raised to y minus e raised to minus y, and again here e raised to y plus e raised to minus y. Now we have to subtract, so this is minus e raised to y plus e raised to minus y. This 2 will get cancelled. Okay, this 2 will get cancelled. So what we have? 1 plus x upon 1 minus x as 2 e raised to y upon 2 e raised to minus y. This 2 will get cancelled. Therefore 1 plus x upon 1 minus x is what? E raised to 2y. Therefore 2y is what? Ln 1 plus x upon 1 minus x, right? Therefore, y is what? That is tan h inverse x, and this is equal to 1 by 2 ln 1 plus x upon 1 minus x. So this is the required result. Okay. So I hope you have understood throughout the session. Thank you for watching.